Good morning, everyone. My name is Corey Carlson. I'm with URETEK Holdings. It's 11 o'clock Eastern Time, so we'd like to go ahead and get started. Be respectful of all of your times. Our webinar will end today at noon, so in 1 hour. In the event we have more questions that go beyond noon, we'll definitely dismiss everyone at noon and then allow those who want to stay on to hear any more questions. Today, very excited about our guest speaker. We have Randy Post. He is a senior project geotechnical engineer with Golder Associates. He's very familiar with chemical grout and very neat to hear perspective from a geotechnical engineer on the different aspects of polyurethane grouting. Before we get started, just a few administrative items I'd like to touch on, and then just give an overview of URETEK Holdings, our company, and then hand it over to Randy. Everyone will be on mute during the webinar, and there is a raise your hand icon to ask a question. Just go ahead and click that, ask the question, or type in your question, and we will address them at the end of the webinar. So about 11:45 we'll have some questions. And then there will be one PDH credit available. Please check with your state just to make sure. I know every state is a little bit different. And then at the end of this webinar, there will be a survey that will be sent to your email address, and that is how you can request that PDH. So who is URETEK Holdings? We are a contractor who is headquartered in Florida. We operate in 31 different states, and we pride ourselves in our safety culture from a low EMR of 0.75. We have a very high ISNet rating of an A, and really strive ourselves on excellence. What makes us unique as a contractor compared to others is we pursue non-conventional solutions. So chemical grout instead of a cementitious grout, going after trenchless technologies as opposed to remove and replace. And so because of that, we utilize sales engineers throughout the country to educate municipalities, geotechnical engineers, civil engineers on our products versus the conventional solutions. Thus, having the monthly webinar series that we do such as this. So one example of what we do is the outside-inside of how we'll go after the infrastructure. For the inside of the structure, we will use permacast for manholes and center pipe for lateral lines and storm and sanitary sewers. You can see the picture on the left. If the invert is deteriorated, we'll put a 12,000 PSI concrete in the invert. And then the next step would be to use a bidirectional spinner to spin a 8,000 PSI to provide a customer with a like-new solution without having to remove the road and the existing pipe. To handle the outside of structures, we'll utilize a chemical grout to stop I&I, to displace the unwanted water, to densify the soils. As you can see by this picture, we will come inside the manhole to inject our material, or we can inject from the surface, whichever will provide us the best solution. Here's a recent project that we did in Clarksville, Indiana, where I&I was causing the community to spend more money on pumping. So we identified 7 manholes that needed to be repaired with the city of Clarksville. We injected our chemical grout through the inside, but on the outside of the structure to encapsulate the structure. With those 7 manholes, we were able to stop I&I, and Clarksville has since reported that they have been able to save $188,000 per month due to the reduction in I&I into their sanitary system. So very fun to see some of the success stories that we're having in our aging infrastructure. What Randy will be talking about is not only the geotechnical aspects of chemical grout, but talk a little bit about the difference between a 1-part and 2-part, when to use them, and the different benefits. We noticed that ourselves out in the marketplace. In this particular project in Baltimore, due to the amount of water underneath the rail, we wanted something that would displace the unwanted water, so we use a two-part grout. Our URETEK 486 grout was the solution that made the most sense to stabilize the soil, as well as to lift the rail 1.5 inches. But at the same time, some projects are specified where you need to use a one-part grout or a permeation grout. That makes the most sense. And this is a project that we worked for the Florida Power and Light to create a cutoff wall. And as you can see kind of by the water in the background of the picture, we were very close to water, so we went with the permeation grout. Now I'd like to hand it over to Randy to further talk about the geotechnical aspects of the chemical grout. And as I mentioned, Randy is a senior project geotechnical engineer with Golder Associates, and now I'll be handing over the screen to him.
Thanks, Corey. Let me know if you can't see my screen or can't hear me all right. Good morning, everyone. I appreciate the opportunity, the invitation from Corey and URETEK Holdings to participate in their webinar here. Looking forward to sharing my perspective. As Corey said, I'm a geotechnical engineer with Golder. I sit in the Tucson, Arizona office, and pretty much my whole 14-year consulting career has been primarily transportation-related geotechnical engineering. And I've had the privilege of getting to know quite a few folks around the URETEK community, and I can say I haven't found one yet that I don't like, that I don't enjoy talking to and working with. It's a great group of people. I will say, you know, I'm definitely not a salesman. I think that's part of the reason why Corey invited me here is, you know, I don't work for them. So my opinion is my own. I'm not going to tell you what I think you want to hear. But I will say I am a big fan of the URETEK products and the solutions that they offer. And I have recommended them to my clients on a number of occasions. And I think that they're a great solution in a lot of cases. And, you know, certainly they don't work all the times, but or I should say they're not the right solution for every project, but they're a great tool to have in the toolbox. And I just also wanted to quickly mention that, you know, I'm very familiar with URETEK, but I don't work with them every day, and so some of the terminology I use, I apologize if there's any confusion there. Certainly, if you're not sure if I use the right word or something related to URETEK products, definitely check in with Corey or one of the other folks from URETEK. So, as a consultant, my main goal is providing the right service to my clients and providing value to them. So my take here and where I'm coming from on this presentation is I want to talk about the URETEK, primarily their deep injection process in geotechnical terms, using my vernacular, and hopefully some of you are probably owners and other engineers, so you can relate to where I'm coming from. But I want to kind of just describe it and how it can solve some of the problems that I see in geotechnical engineering and when it's appropriate. And then we'll talk a little bit about how it compares with some other types of ground improvement and grouting, and a couple of not quite as mainstream ideas for how to apply URETEK. Some of them I've seen, I know are currently being used, have been used on projects. Others are just, you know, my ideas on what might be possible. So I didn't want to, I know most folks on the call probably have had a visit with one of Corey's sales engineers or one of the other affiliates sales folks and have gotten an overview, but I didn't want to leave anyone behind. So just real quickly, I'll go through what the basics of the URETEK deep injection um, process is. And the URETEK method is more of the slab lifting, where they're dealing with shallow injections and addressing issues closer to the surface. And the deep injection is something that goes as deep as 30 feet is a sort of a typical range that they can go. The spacings, from what I understand, tend to be about 3 feet to 4 feet in plan, and then the vertical spacing could be something similar depending on the project. And what they're doing is injecting this two-component polyurethane that has a very fast chemical reaction. That the mixture happens right out the gun as they're injecting it, and that it releases carbon dioxide, which is what causes the expansion, and it cures very rapidly. So the reaction is essentially complete within about a minute, and you can achieve very high strengths within a matter of minutes to hours, and full strength in about 24 hours if I have the correct information. And they have a couple different products with slightly different properties in terms of strength or density, and they can make tweaks to the reaction time depending on the product, or depending on the project. So they can tailor it to the soil conditions and the project conditions. I would consider the deep injection as a form of ground improvement. So in some cases it's a grouting solution, but I think it also qualifies as a ground improvement technology. And like I said, it's another tool in the toolbox, and I think it has a lot of advantages and excellent applications. But in some cases it may not be the perfect solution. So. But I think I've found that the URETEK folks I've dealt with are pretty upfront about what it can do and what it can't do. One of the things it's excellent at is void filling, and so that's the first mode of ground improvement that I'll touch on. But you can also get, depending on the formation, that polyurethane can permeate through the soil, sort of fill in void space. I'll talk about this geopolymer lattice or structure, which is another way that it can improve the soil, and then densification. So the void filling, this is something that works great for in their industrial and roadway applications, where if you've got a settled slab or settled pavement or curb or something like that, you can fill in the voids that are causing the settlement. You can even lift settled structures. So I think most of you have heard information from URETEK on some of those capabilities. In terms of settlement, if you have settlement issues that are caused by weak soil conditions, and then the weight of the structure and the weight of the soil is what's causing that settlement. So one of the nice things about the URETEK solution compared to some other options, some other grouting options, mud jacking and things like that, is that the unit weight of this material is very low. So the free rise density is in the neighborhood of 4 pounds per cubic foot, and I think in situ it's maybe closer to 20. And so that you're not adding a bunch of extra weight, which could just actually make your problem worse, your settlement problem. So that's another nice advantage. But Corey mentioned that they use this the URETEK products to seal around manholes and fill voids there. So pretty much anytime you've got water moving around infrastructure, if you've got a water leak, then it's pretty likely that there's soil moving along with that, and so there's a void there that has to be addressed. So it's not just about sealing up the leak, but also filling that void. And abandoned utilities, that's another application for the URETEK product. So the permeation, what I call the permeation mode or binding mode, is it's really applicable to coarser grain soils that have some connectivity between the void space. So when you inject the polyurethane, the um, the grout fills in the void spaces without significantly changing the structure of the soil, at least initially. So basically what you're doing is creating an artificial sandstone. So this picture here, this was you can see the floating heads in the background there. This was I think about a 3 foot by 3 foot test soil box that they created for demonstration purposes, and this was a gravel sub-base layer that they were injecting the polyurethane into. So you can see, it filled in all the voids and made a like a one sort of uniform, relatively uniform material. So I mentioned it's about the void space. This is kind of amusing. I didn't realize till I blew this picture up that somebody had made some lightning-shaped soil particles, but I think that's pretty cool. But basically, this permeation mode works when there's enough connectivity and enough void space for the polymer to flow through there. And one of the cool things about the URETEK product is that it doesn't react, it's hydro insensitive, so it'll actually push water out of void spaces and replace it with the foam. So when do you see this permeation mode? This is just an example grain size curve. It's not meant to be something that you could actually use on a project, but basically when you get the permeation versus other types of formations of the lattice, which I'll talk about next, it's a function of the grain size, it's a function of the density, the void space, and so really this is something that you see with the coarser soils. When you start getting reduced void space and finer grain size, then you're gonna see more of the next type of improvement that I'll talk about, which is the lattice structure. So, but basically, like I mentioned here, the URETEK folks that have been doing this work for years, they have a pretty good idea for the local soils in their area what kind of results you're going to get. So talk to them; they're a great resource. This is, Corey mentioned that I'd talk a little bit about some of the other types of grouting. This is a figure for chemical grouts showing sort of the range of permeabilities where you can inject this material. And I think, so polyurethane is down at the bottom there. I think it could probably extend a little bit more into the silts, but I think as you start moving to the right there, the reduced permeability, the lower grain size, or smaller grain size, I think that's when you're going to get into this lattice structure that I'm going to talk about next. But you can see, I mean, this is the polyurethane's comparable to some of these other forms of chemical grout. So this is what I'm referring to when I talk about the geopolymer lattice. It's when you have this lower permeability soil, you can end up with these veins of the polyurethane, or stringers I call them, or webs. I'm sure there's probably other terms that folks have used, but it's a relatively random pattern, and the material's following the path of least resistance. So that's actually not a bad thing, because you're basically the improvements in the soil are happening where it's needed most, where the soil's a bit weaker. And the densification, this is something that I think is one of the really unique aspects of the URETEK's deep injection product here, or process, and that's that you can actually have some densification of the soil. So for that to happen, though, you need confinement. So once the some of the voids have been filled, the cracks and the fissures in the soil formation have been filled up, and you started to kind of seal things up a little bit, that's when you start seeing the density improvements. So, and here I talked about with the permeation grouting, you're not really changing the structure of the soil. With the densification, you're rearranging the soil particles into a more dense configuration. And this has a number of benefits, from a geotechnical perspective that including strength and stiffness and reduced permeability, all depending on the project, those are all things that are definitely desirable. And so the little schematic here just sort of shows you the general idea here that the pressure and I should mention that the pressure is not applied by the injection gun. The pressure is from that's causing this densification is from the chemical reaction itself. So it's happening, at the injection point, and it's independent of or relatively independent of the pressure at which they inject it at the surface. This is what's happening down below. And it's probably not quite that uniform either. So, and I should mention too that this is, it's really about physics is what it is, because you can't have two objects occupying the same space. So if you can verify that you are injecting this material, it's going to expand. It has to go somewhere. And if there's nowhere for it to go, if it's filled in all those paths of least resistance, then it's going to start affecting the soil and pushing things out. So it may be, and I'll touch on this issue, it's difficult to quantify that. It's really hard to see what's going on under the ground. But if you can contain that polyurethane in that within a particular area, then it's going to affect the soil, and it's going to cause some densification. So this, from what I understand, this is one of probably the most asked questions by other geotechnical engineers like me, by owners. What's my bearing capacity increase going to be after the deep injection? What's my shear strength increase going to be? It's not an easy question to answer, and I'll talk more about why as well. But what I think would be useful for you folks on the call is just to kind of go through a very basic but very, I think, theoretically sound way of looking at what the potential increase is. So this table here, you don't need to worry about being able to read it or anything, but this is something that I'm sure Corey or his staff, other affiliates can make readily available to you on the properties of the different materials that they have. I'm going to focus on two in particular, a 4, oops, there's a typo, that should say 4 PCF mix, and it's got with a compressive strength of 60 psi. And then also look at one of the higher density materials that they have, the 8 PCF. And that when they're talking about density, they're talking about free rise density. So that means that they inject it into a container without any confinement and then just let it rise. And then when the reaction's complete, then they measure the density. So in the ground, when you have a little more confinement, you're going to see that density is actually going to be higher. If you pull a sample out of the ground and you test it, it's going to be a higher density than that. But from what I understand, probably around in the neighborhood of 20 pounds per cubic foot. I'm focusing on the compressive strength. I know they have a line here, the bottom boxes for shear strength. I just wasn't as familiar with that particular test method. It's not one that we use in geotechnical engineering. It's a one for plastics. So what I did was something common in geotechnical engineering. I just took the shear strength of this material as half of the compressive strength for this illustration that I'm going to walk through here. So this is the engineers in the audience will hopefully be able to follow along, but basically what we're on the x-axis, we have normal stress. So that's essentially the confinement that the soil feels in the ground. So, and that's going to be a function of depth. So the 25 PSI, that correlates to roughly 30 feet of overburden, which would be the sort of what's commonly used as the limits of the deep injection process, about 30 feet. So you can think of the x-axis as kind of an analog for depth. And then on the y-axis is the shear strength. So the shear strength varies of a soil, or depending on the confinement, on the depth at which you're looking at. So I plotted here in green a couple different cohesionless soils with different friction angles. So you can see the bottom curve would be the 30 degree and 35 in the middle and 40. And also a couple of cohesive soils, a stiff clay and a hard clay. So you may think, oh, the strength of this polyurethane, it's only 60 psi compressive strength. That's not very good, if you're thinking about comparing it to a concrete. But you can see that red line up at the top. I mean, that's half of the compressive strength of the 4 PCF product. It's still significantly stronger than pretty much any of the soils that you're going to encounter. And that's, I think, probably the actual strength is probably going to be higher than that. For the other product that I'm using in this comparison here, that 8 PCF, that's half of 175 is about 88 psi. So that's off the chart. So that the first thing I wanted to point out is that this material does definitely have strength, and it's not, this is not a weak material. So now what I did then is just take assuming a simple volume replacement. So assuming there's some pore space in there that you can fill with when you're doing the deep injection, you can fill with this material. What happens, for example, if I do a 3% volume replacement of, and for this example, I'm using the 30 degree friction angle soil. So we have a 30 degree friction angle soil. That's this bottom dashed green line. And I replace that with 3%, or replace 3% of the volume with the higher strength material. And what I end up with is this black line. So you can see that it's essentially at shallow depths, it's definitely higher than even the 40 degree friction angle material. And then towards the deeper depths, it's still fairly close to the 35 degree friction angle. So it doesn't mean, so this is kind of obviously a kind of a simplified model here, but I wanted to just kind of illustrate that if you can feel comfortable that you've put that much material into the ground, then there is definitely going to be a shear strength increase. So and this black line too, if you, instead of the 8 PCF material, one of the more common ones that they use is the 4 PCF product, which has slightly lower, that's the red line there up at the top. So if you can do 10% volume replacement, that's roughly equivalent to what that black line is showing right there. And then just for grins, if you've used the 8 PCF material, the stronger material I'm using in my example here, if you do 15% volume replacement, then you're talking about this upper dashed line. So the question about, is there shear strength improvement with this material? I think there's a very good theoretical basis for saying, yeah, there's definitely a shear strength increase here. It's a lot harder to quantify that in the field. It's really hard to grab samples. It's really hard to run lab tests on this. But I think there's a sound theoretical basis for the shear strength improvement. So you can, one other thing, I mentioned it here, but you definitely have a really high improvement in the strength closer to the surface. And as you get a little bit deeper towards the right side of the graph, it's not quite as significant of an increase, but I would say that at those depths, you're also going to, you will often also get an increase in strength as a result of density increase too. So to talk about that a little bit more, about how the density relates to strength increase, this is a figure, I think I modified it slightly, from a very well-known reference in geotechnical engineering from the Navy, NAVFAC. And so we've got dry unit weight of the soil on the x-axis, we've got friction angle on the y-axis. So if we take this curve here for poorly graded sand, as we move to the right, increasing in density with the same soil type, so the point on the left, 100 PCF of dry unit weight, we've got about a 30-degree friction angle, and at 110 PCF dry unit weight, we're up above 35 degrees friction angle. So the thing I just wanted to point out here is that there's definitely an increase in your shear strength if you can densify your soil, even without doing anything else. So we've basically, you know, with this deep injection method, there's two potential ways that you can increase your shear strength. One, just getting the material in the ground, the strength of the material itself improves your shear strength. And then also, if you've got some densification effect, you're also going to see shear strength improvements that way. So another way that the URETEK products can help deal with some of the issues that we see in geotechnical engineering is a stiffness increase. So if you've got settlement issues, excessive settlements, so a lot of times you see this URETEK being called in after there's been a problem. What I kind of wonder too is, you know, I don't see any reason why you couldn't do this ahead of time when you identify a potential settlement issue before you build the structure, rather than over excavate and replace, or over excavate and recompact, or some other methods of ground improvement. I think there's strong potential to look at the URETEK as another option to densify your soil, to help stiffen it up and reduce your settlement potential or increase your stiffness. Another geotechnical challenge that folks like me face on various projects is related to water or even potential contaminants moving through your soil. So the picture up in the upper right is from a project in southeast Texas. There was an effluent pond that was part of the wastewater treatment facility in the area, and it was used to water golf courses. And there's this embankment that was retaining that water, and with a creek on the downstream side of the embankment. And they were having seepage issues where you could visibly see water coming, seeping through the embankment and into the creek. So created some obvious water quality concerns in the creek, and also there was quite enough water coming out of the embankment, or out of the pond, that they didn't have the water they needed to for their golf courses. So they were able to inject use URETEK's deep injection and visibly confirm that they were significantly reducing the outflows from the toe of the embankment here. And URETEK Holdings has been one of the URETEK affiliates that has done quite a bit of work with cutoff wall applications. So I think Corey mentioned they had an injectable barrier. It was a topic of one of their previous webinars. And so I want to talk briefly about that. This is something that I find particularly interesting and really potentially useful for engineers like me, and hopefully for owners and other folks as well. So I'll talk a little bit. I'm going to talk about a study that was done on one of their projects by Handex Consulting and Remediation LLC, and I want to thank Bob Moody with URETEK Holdings for getting permission for me to use some of their slides and discuss this project. So HCR presented on this project at a conference in 2013. It was in Palm Beach, Florida, on State Route 704. On the left side of that image there is an existing, currently operating gas station with a contaminant issue, They have an operating treatment system that's managing the issue, but the DOT was going to have an excavation for a structure that was close there, and and the groundwater is at about 9 feet, and they were going to need to dewater to 15 feet. So they were concerned that the dewatering would pull some of the contaminant plume into their dewatering wells, and then they'd have contaminants to deal with. HCR and URETEK Holdings were involved in a solution here to use the deep injection, their injectable barrier solution to provide a cutoff wall, and they used 2 monitoring wells so that they could see how the cutoff wall performed. The spacing of the injection points in plan was 3 feet, 3 feet horizontal spacing, and then they had 5 different depths. So you can see on the left, the picture on the right is them installing some of the injection tubes, and on the left you can see that they needed 2 holes to get the 5 depths, 5 depth points for the injection. Hopefully you can see these graphs okay, that they only needed to dewater for about 7 days, so I think these time series graphs show about pretty much the whole duration there of the dewatering. And so the monitoring well on the left is the one behind the cutoff wall. On the contaminant side, the one on the right is on the dewatering side. And you can see that they achieved really good results with the cutoff wall. The change in static water table really stayed right at 0. There was no drawdown on the contaminant side of the cutoff wall. And so, quantifying your permeability reductions, that's something. I think this is not unique to just the URETEK solution here, but any kind of cutoff wall application, you're going to have a way of quantifying your improvements in permeability. So I know there is at least one study that's currently going on at University of South Florida to better quantify this improvement, but certainly in this project it's worked well, and like I said, I think URETEK Holdings has done about 8 of these projects to date, a lot of them for Florida DOT, and with good results. So I think there's a lot of potential here for this application. Another sort of geotechnical problem sometimes we encounter, and one that I think is just another neat application, is for sealing up leaking structures. So these are, I opted not to try and show the video over the webinar here. It was just going to be too choppy, but the picture on the upper right here shows a duct bank penetration through a utility vault, and the water is just pouring in. And the video is only two minutes long, and that includes fixing this port plus one other port. So you can see they start injecting there, and literally within a minute they've sealed up and this is all while the water's pouring in. They seal it up and they're done, and they move on to the second port. So I put the links in here. Hopefully the links will work when Robert and Corey send out the slide notes from this presentation, so I highly encourage you to check it out. It's pretty impressive. And sort of similarly, on the left, the manhole project, Corey talked about that briefly, and he talked about their Baltimore project with the rail lines. And I mean, that video is interesting too, just because you can see as the train, it's the dark shape in the background there is actually a train going by, and so when it goes over the tracks, the water is actually squirting up out of the ground. I mean, that's obviously not a good situation, and so I think that just speaks to one of the unique properties of the URETEK products is that it's not, you can inject it underwater, it doesn't react with the water, and it's safe to inject in potable water. So it's a really neat application. So again, these are, I think, some really good applications, and I wouldn't have any reservations recommending the URETEK for situations like this for any of my clients. So we're with the last few minutes here, I'll go through these slides pretty quickly, but I want to just talk about how the polyurethane, and that's PU, polyurethane grouting, compares with two other types of grouting. So one type that I want to talk about is the permeation grouting. So permeation grout, probably two of the more common types are either cement. You can have cement based, but more often than not it's a sodium silicate based product which has a catalyst. So I mentioned that polyurethane is not you can inject it in the presence of water. The sodium silicate can get diluted in the presence of water, and if you dilute it below a certain point, then the reaction time won't work. Or the reaction may not work at all. The cure times of the polyurethane is very fast. The permeation grout for the sodium silicate is definitely longer. There's no expansion with the sodium silicate with the other types of permeation grouts. With the polyurethane, you've seen the pictures and you probably are familiar with how that's installed. It's a single injection points. They can really target where they want it to go. With the permeation grout, they're doing a grout manifold where they're injecting, they'll drill multiple holes. They're all connected to the same pumps and stuff, and they're injecting the grout at multiple locations at the same time. And I think the biggest difference here is definitely related to the water. That polyurethane grout is really not sensitive to changes in the presence of water, or and it works in a variety of temperatures as well. Compaction grouting is one type of grouting where you can also get the densification effect, and so I thought it was worthwhile taking a quick look at this as well. The polyurethane is definitely more high mobility. The compaction grouting is a very low mobility grout, and you end up with the conventional compaction grouting, you end up with sort of a column of bulb-shaped concrete inclusions. The shape of the polyurethane is definitely a little more variable. And the compaction grouting, the biggest difference I think is that the compaction grouting, the pressure you are injecting with at the surface, accounting for losses in the pipes and everything, that's the pressure that's doing the soil improvement at the injection point. Whereas with polyurethane, the pressure at the surface doesn't really mean a whole lot to you. It's really the pressure that's being achieved by the chemical reaction. That's what's causing the soil improvement. In both cases, watching for minute ground surface movements is one of the quality assurance methods, and in both cases you need the confining pressure so that the grout stays where it's supposed to be working. And I think another thing to point out is the differences in just the installation equipment and the footprint of the whole operation is quite a bit different between the polyurethane grouting and the compaction grouting. Just to expand on that a little bit, this is another reason why I like to recommend the URETEK deep injection to my clients, is that this is pretty much what you need for a URETEK job. You've got a trailer or a panel truck or something with all the equipment and like a 3 or 4 man crew. It installs quickly. They can open things back up to traffic or operation very quickly, and it's pretty easy for them to clean up. If some of the foam squirts out, makes it to the surface someplace, you just peel it up. So I'm starting to run a little long here. I apologize, but I think we just got a couple minutes left here. So geotechnical characterization, this is something that is a real challenge because we talked about the different modes of soil improvement. So it's a complex process that's going on in the ground that's achieving the improvements. And we also have talked quite a bit about the pressure that it's not, we don't have a good instrumented pressure reading at where the reaction is happening, where the action is down in the ground. And the polyurethane follows that path of least resistance, so it's not a very uniform improvement in a lot of cases, particularly when you're looking at that lattice type of structure. So with that in mind, the field tests, and this is a picture of someone running a dynamic cone penetrometer, the field tests, and even if you were to excavate and grab samples, it's really challenging to get good representative samples that will tell you what's going on. But I did want to point out that this is not something that's just unique to polyurethane grouting. That pretty much almost all types of grouting have this issue. It's a real challenge. So I don't have certainly don't have all the answers here on this, but I think it's something that will continue to be a challenge for our geotechnical engineers like me. But it's something that we're definitely giving it a lot of consideration. So just to wrap up here, a couple different opportunities I see, thinking about projects that I've encountered, needs that I've seen from my clients, and is mine reclamation. I think there's a lot of potential opportunities there. And also I think that URETEK, their deep injection, should be given some consideration for pre-construction applications too, that there's some real potential advantages. And I've seen some drainage structures around here that are just really prone to leaking and causing distress around them. You always have, it's not uncommon to see a dip in the road around an inlet structure or something like that, because either water's getting out and creating problems in the soils, or water from outside is leaking in and taking some soil with it, leaving voids behind. So, maybe sealing around these things ahead of time could maybe create some savings down the road. I think there's a lot of potential too for in excavation. So in between soldier piles, where you're getting your soil ground retention, your earth retention from soldier piles, but you still have to deal with making sure the soil doesn't spill out in between. So we were going to try this on one of my projects and didn't quite, the project changed a little bit, so we didn't get to try it, but I'm kind of wondering if that might be one potential application here. I know there was one project that I'm aware of in California where Caltrans had a slope failure issue, and they injected the polyurethane actually in the slide plane to sort of seal it up and prevent moisture from moving through there, and then treating some of the other voids caused by the ground movement before they fix the road. I think that's a really interesting and unique application. I'd like to look and see if there's some other opportunities to do that on my projects, and definitely would be curious if anybody else has tried that. We talked a lot about the cutoff wall applications, but I think another sort of similar application would be sheet piles. I don't do that a lot in my practice here in the Southwest, but definitely, sheet pile seals are notorious for leaking, particularly as they age. So this is an opportunity to get some more life out of a sheet pile wall that may be fine structurally, but is just creating issues because it's leaking. So this, I think, is something that would be worth looking at. So that's all I have. So Sorry I went a little bit longer than I had planned, but hopefully I think we still left some time for questions. So.
Great, Randy. This is Robert. I'll go ahead and ask some questions. Just going to give a little bit of direction here. If you look in your webinar tool area, you'll see a questions section within that. Feel free to submit your questions there. Unfortunately, due to the size of the audience, we won't be able to utilize microphones or the hand raise today. So please submit your questions in that area. So I'll go ahead and continue with the first question. First question is, how do you prevent cracks due to the expansion of the material?
How do you prevent cracks? I'm guessing that you're talking about cracks in like your structure. You know, I think that's probably something I would defer to Corey or one of the URETEK guys, because this is obviously something they've been doing for quite a long time. So. And I'm sure anytime you're dealing with grouting.
Yeah, Randy, I can step in.
Yeah, go ahead.
Yeah, for existing infrastructure, if there are any existing cracks, the way that we inject our materials, we do a couple things. We will have laser equipment at the surface. So if we do not want to have any lift, then we will make sure we're not getting lift. And as you watch some of those videos that Randy mentioned, you'll hear in the sounds where basically the person on the gun will pull the trigger and then release. We call it, the pulsing. And if we were just to pull the trigger and let the material flow, then yes, bad things could happen. But by just pulling the trigger quickly, releasing, letting it expand and cure, and then we inject again. Due to the quick amount of time that it can cure, we can inject and then inject more material. So that's how we control it. So we are not doing any damage to existing cracks. It is really by that surgical application.
Okay, great. Next question is, if you were to inject in a granular soil, sandy gravel, is it diggable? Is it still diggable? For instance, if you use this to jack a section of road and needed to come back later to install utilities, does the product crack, crumble, etc., and become less stable during excavation?
I've seen some pictures where it's been excavated. I'm not. I think would be similar to like a flowable fill kind of situation, where I think you could probably excavate it pretty cleanly, and it doesn't deteriorate. I saw some examples, and I don't know if this is a case study or something that Corey can send you, but where rail facility owner was looking at injecting under some concrete panels for crossings, and they wanted to see if they could, pick up the panel and reuse it somewhere else. And they lifted it up, and the polyurethane is they're in great shape. I think it does deteriorate in the sunlight, but it's very good durability, long life, and I'm pretty sure that you can excavate it. And I don't know if Corey, if you have any examples of or if you've seen projects where they've gone back and then dug it out, but my guess is that it would be kind of comparable to excavating out like a flowable fill material after you had placed that, which is definitely doable.
I think that's correct. Corey, did you want to highlight on that, or you feel it was covered?
It's covered. He's correct. It can be excavated.
Okay, thank you. Next question. If injected under muck areas, will it improve the stability and perhaps avoid surcharge?
By muck, I'm guessing you're thinking like maybe organic soils, and I know that URETEK USA has done some research on that, improving peat soils, and it definitely I think one of the things that it can do there too is it'll drive out moisture for starters, so that densification action will definitely help to drive some of the moisture out, but also kind of encapsulate some of those material, and so there's definitely some benefits there. I haven't used it in that application myself, so I can't say for sure, but I do know that there has been some research done, and there was a URETEK USA did some work in a really large soil, I forget what you would call it, but basically a giant soil box at University in Florida, and they were testing this out as a means of improving peat soils, and I think the results were favorable. So, but I can't speak to it from my own experience.
And we have a study on that peat as well, so if anybody is interested in seeing that, we can certainly pass it on. Next question is, when would you use permeation instead of polyurethane grouting?
Let's see, that's a good question. I think if I was looking for, if depth was a concern, certainly anything for a deeper improvement project where 30 feet wasn't going to get me what I needed, I think I would maybe consider definitely looking into other options as well. If it was really a uniform material where I wouldn't be too concerned about having multiple injection points all kind of operating on at the same time, where you just kind of not flooding, but really kind of installing the material across a wide area at the same time. Then there might be some potential cost savings there. I'm trying to think what some of the other. I think like most engineers, when it comes to an application like that, I would probably be considering both, for just about every project, and making sure I pick the right one for my project and for my client, and then at the end of the day, if they would both do the job, then I'm going to look at costs, and my gut is that the polyurethane grouting is going to be pretty cost effective, but you'd have to kind of check it out on project by project.
Okay, excellent. Corey, it's 11:58. Do you want to break for the moment? I mean, go finish to allow people who need to move, and then we can continue on. We have about 8 questions still on the queue.
Yeah, that is a great here. I'll just change into my screen real quick. First of all, thanks everyone who was on this webinar. We want to be respectful of everyone's time, and so we will, I guess, formally adjourn the webinar now. Please stay on for those additional questions that Robert had mentioned. Our next webinar will be on January 29th at 11 o'clock Eastern, and George Kurz is a consulting engineer who's basically pushing on the I&I issues in our country. He recently has wrote an article on how much I&I is leaking into that sanitary system, and his test was on Tennessee, which he believes he was able to get a majority of the infrastructure inventory, and was calculated that 44% I&I was coming into the system with the sanitary was pumping. So very significant, and it'll be a very interesting webinar we'll have January 29th. And then, please stay connected with us via social media, as well as our monthly newsletter and webinar, so we can continue to stay connected and help you with any of your projects. So I guess formally, thank you very much for being on the webinar. Feel free to sign off, and then we'll continue to address questions for any of those that have them. Thank you.
Okay, great. So I'll go ahead and continue with the questions. Again, we've got about 8 more here, and they're all very intriguing. So the next question is, what is the lifetime of the product, and what are the long-term environmental effects of the material degradation?
That sounds like a good Corey question.
We have a list of different chemicals and how it is affected, and really almost every single chemical, if it is in a normal soil state, it is diluted, we're going to be okay. We don't have to worry about that. As Randy mentioned earlier, UV, it will break the material down, but that is not a concern because everything we do is under the ground. There have been applications where we will be the grout to fill in between the host and the new pipe for a slip line project, and in the event that grout is exposed at the end of that pipe, we will just paint. We'll basically put a sealant over it. But we can provide the list of any chemicals, but really in a normal soil condition, it is not a concern due to dilution.
Yeah, and I think just to expand on that, I think he's also talking about like long-term stability of the product. I mean, it doesn't break down. You guys have had some studies where you've excavated it after many years, and it basically looks the same as when you installed it.
That is correct. And not only looks the same, but individuals who have been at excavations that are 20 plus years old will say it smells the same for whatever that is worth.
All right. The next question is it cost effective to use over a large area, such as to seal or densify along a tunnel? How does cost compare to sodium silicate?
Every project is definitely different. We actually just recently were working on a project in a tunnel at Chicago O'Hare Airport, where we were the most cost-effective solution. Working on a tunnel, it's more of a injection at the joints, and we will just take a look at what we believe to be the voids on the outside of the joint. So how much material are we going to need to use, as well as really the accessibility of it. But we do both one part of permeation grout as well as two part. So even ourselves, we will take a look to see what the most economical solution is for the customer based on what we can provide. And for our tunnels, we have found that the two-part grout has been the most economical. And a lot of times what also helps for the customer is the faster cure time. So that faster cure time allows the tunnel to get back in service, or us to continue to move on to further parts of the tunnel.
Okay, great. How are the deep grout points advanced to 30 feet?
Basically, we'll use injection rods that are at the various lengths. So we need to use a driller to get to those depths, then we will. For shallower depths, we'll just use a Hilti drill. But for our various depths, we actually have a dedicated length rod for that. It's not necessarily an extension or kind of pushing it down, if you will. We will drill a hole, and then we'll insert a rod at that desired length.
I saw in some pictures you might have seen in the presentation too. There was one with like a scissor lift. So that was basically so they could get the drill up high enough with that single rod and just drill it all in one motion. Is that pretty common, Corey?
Yeah, that is correct. Yes, that is correct. If we can do that, for sure.
Okay, so the next question is polyurethane capable of resisting acidic groundwater?
I think the literature that I've seen is that it holds up very well under acidic conditions. It's only like some very concentrated acids that give it problems. Is that a fair statement, Corey?
That is a fair statement. We've also had projects where we've had very unique soil conditions. Maybe there are contaminants that are in the ground. We are we work very well with our suppliers and the engineers who provide the material, and we can make modifications based on the soil samples at that project site. And so if you have a particular project that you believe is going to be very challenging for really any of the methods that you know to be true, then pull us in. We can do the soil samples and we can make modifications to our material, and so let us know on that particular project. But off the shelf, yes, we can handle almost every type of soil conditions, but we're more than happy to figure out a solution together.
Okay, how does URETEK deal with uniformity and densification if it is so difficult to achieve?
Every project that we do, we look to get soil borings, and so we have an idea of what the soil conditions look like. We also utilize DCP test, and based on the information, we know how much material we are injecting out of the gun, because we measure it, and then also by knowing its expansive characteristics, we are able to quantify what we are putting in the soil due to the type of soil as well as the voids that are present and the void ratio of the soil.
Yeah, I think just to add on to what Corey was saying, it is a challenge, and it's definitely not a uniform improvement across the area that you're injecting in. But like you said, I think it's the best approach currently is to have the detailed records that he was mentioning on how much material is injecting. I have seen some relationships on what's the density of the material under different confining pressure. So you can make some you can make some assumptions there based on your overburden and things like that. And you have to, the biggest X factor in my book is if you have weak seams or things like that and the grout can get away from you a little bit. Trying to quantify that is I mean, that's that's really challenging, but that's not just a problem with polyurethane grouting either. I mean, you can get that with any type of grouting where you start injecting and it could go be flowing somewhere you weren't expecting. So, but I guess one of the nice things with the polyurethane is that the reaction time is so quick that if it is going somewhere, it's going to start sealing up. Whereas some like a cement-based grout, you could be filling a storm drain for a couple hours before you ever realize what's going on or where that material is going. So, but that's a great question. I think it's the $100 million question right now from my perspective as a geotechnical engineer, who would be looking to use this on one of my projects as, how do we, verify? And I think right now, I think the best approach is just to look at the amount of material that you're putting in there and be conservative and make sure you have some safety factors in there for what you're looking for in terms of soil improvement and verify it that way.
Okay, great. Next question is, in the southeastern Piedmont, we often have considerable depth of compressionable fine-grained silts and silty sand soils. Do you have case studies in this type of geological setting where soil permeation, ground improvement can be achieved, limiting strain potential under load?
Yes, we do have a lot of different case studies for the Southeast, and we'd be more than happy to share those with you. So we'll follow up after the call for that individual.
Okay, great. How do you use multiple depth injections as opposed to retracting a single injection pipe during the process to better distribute polyurethane through the soil column?
We have done a couple different methods. Our tubes, our injection rods are sacrificial. So as Randy mentioned, the various depths that we have will be individual rods for those depths. So if we're going, -6, -9, -12, those will be 3 different rods. And so we'll put them in the ground. We have done projects where we will do an extraction of the rod and almost like a tuba manchette process that you utilize on a 1-part grout. We've done, we can do something similar to that. If we feel that's the right solution, you have to worry about rapid cure time as you are extracting the rod, and sometimes it can, get rather sticky and start to cure before you're ready. So we'll evaluate every job on a case-by-case basis, but what we have found to be really the majority of the time the most effective way to get is to use individual rods for the individual depths.
Thank you. So the next question is, to what extent can it be used to underpin an existing foundation where an excavation is immediately adjacent? How deep?
I think that's something that URETEK collectively has some pretty good case studies on. I mean, that's one of their bread and butter sort of underpinning type of application. So I think, and looking at some of the stuff I was talking about with your shear strength improvements today, I think you can improve things, sufficiently to have a pretty good shear strength and pretty good face control there. But I'm guessing there are probably some case studies that you can point to as well, right, Corey?
There are some case studies. Yes, it's a very good solution when you have an adjacent building, because you can't, the neighbors or the noise, you can't handle the vibratory methods of installing conventional solutions like a sheet pile. Therefore, the injections of chemical grout can work very well. So yes, we do have case studies that we can provide, and it is a solution that we work on very often.
All right. The next question is, could you mix the permeation in concrete or silica with the polyurethane grouting, or will it chemically endanger the polyurethane grout?
I can't answer the question about mixing them together. What I do know is we have done jobs utilizing both, and we'll inject the permeation grout first, and then come back with and do the 2-part grout. So there have been jobs where the two have been utilized together. I don't know about combining them and if that's even necessarily feasible.
Great. So the next question is, how resistant is URETEK to hydrocarbons?
Well, I think the cutoff wall applications are a perfect example of that it's a really good fit for situations like that, because those are, I think, in probably all 8 of those projects, it was, well, that's not true. There was a couple different chemical types that they were dealing with, but I know there were several, like that gas station leak that I talked about, and they've had a few others like that the material is, I don't think it reacts with hydrocarbons. I think it's very stable in the presence of hydrocarbons, but again, I keep deferring to you, Corey, but really it's your product here, so you're the expert, not me. But
I appreciate it. I mean, there's many people on this phone who could help, or webinar, who could help answer some of these questions. I'd definitely like for you to always have that first crack at it, so they don't always hear necessarily my approach, and like to hear the geotechnical engineer's answer. So no, I appreciate it. But no, that's exactly right. It does work well. Those injectable barriers that we have done have been for a variety of reasons, whether it's water containment or contaminants, and so we do not see it to be a problem with the hydrocarbons.
Okay, and one last question. Are there any studies being performed to extend the curing time of the injectable barriers and thus allow for deeper injection into limestone media?
We actually are doing a study right now in Florida for injectable barriers that we have actually just injected here within the last week in the Tampa area, and working with USF to do some additional research on the limestone component itself. Yeah, okay, I can't speak to it at this time. We'll get back to you on that. But there is an injectable barrier study to really kind of see on some of the different aspects of permeability, kind of cure time, as well as coverage area, to just get a better handle on that with some third-party data and a good rapport with the university. So,
Now, Corey, you guys can play around with the cure time a little bit based on controlling the temperature and stuff of the material before injection. Is that right? Because I have heard of a few cases where they've injected deeper than 30 feet, but it's not common. Is that a fair statement?
well, it is not common to go beyond 30 feet depth, really just due to customer needs, if you will. We have and can go to greater depths, and you are right. It's, a lot of times it's a function of the temperature that we have. So you saw some pictures of the trailers. Most of our jobs, we will use a trailer that has the two totes of the material inside the trailer, as well as the generator. We do have a skid mounted unit for smaller applications such as tunnels that we can utilize, but most of the time, we show up to a job site with really everything on that truck that you saw the picture on throughout the presentation, and we can adjust the temperature if we need to based on really any of the variety of conditions. Is it the depth we're trying to go to? Is it the way it's kind of reacting in the soil? So we can make adjustments. So thanks for bringing that up, Randy.
All right, and that is it for the questions. That is it for the questions, Corey.
Okay, excellent, thanks. Well, that wraps it up. Thank you all very much for staying on the webinar for this long. Still, let us know if you have any more questions. Follow up via email. Stay connected with us through social media. And Randy, thank you very much for your time today and really just giving us your perspective on the chemical grout industry. So thank you very much, Randy. It was an honor to have you on our webinar speaking to our customers. So thank you very much, and all of you have a very good weekend, and we'll see you on the next webinar in January. Thank you.
Happy holidays, everyone. Look forward to seeing you in 2016.